Hello everyone, my name is Joydeep Banik and today I am going to teach you about Linux architecture, the Linux philosophy and components of Linux. Starting with the Linux architecture. If you've seen my previous video, I have talked a bit about the Linux architecture and how it is a bit different from the Windows architecture. Let's just revise it a bit. The Linux architecture can be layered as following. So the Linux architecture basically has layers about how you can distinguish them. The first comes layer 1. I am writing L1 for short. L1 contains the hardware. Now what is this hardware? It can be your hard drives, it is your RAM, CPU, etc. From layer 1 we come to layer 2. Layer 2 contains the kernel. By now I think you are sure about what kernel is. If you are not, please watch my previous videos where I have discussed kernel in detail. I'm just going to recap a small portion of the kernel. The kernel is basically a core interface which connects the hardware and the software. From kernel we have layer 3, which is the shell. Now what is the shell? I also have discussed earlier, but let me just recap. Shell is the command line interface between the user and the operating system. The user can type in various commands to perform various operations across the operating system. From shell it comes to layer 4, which is system utility. I'm just writing SYS for short. Now what is system utility? Apart from the shell, the kernel, the operating system has various other features like apps, their inbuilt antivirus systems. So each and every function that the operating system has to offer to the user, it comes under system utility. So, and at the last layer, in layer 5, it's you or the user. So the flow is something like this. The user performs an operation to either the system utility, okay, or performs an operation directly to the shell through commands. CMD. I am writing CMD for short. CMD means commands. The user can perform operations to the system utilities or to directly the shell. The shell then interconnects with the hardware via the kernel. I told you earlier the kernel is the middleman between the software and the hardware, and then the required changes are done in the hardware system and you get, or the user gets, the desired output. This was about the Linux architecture. Now coming to Linux philosophy. Linux follows a different philosophy than other operating systems like Windows and Mac OS. In Linux, everything is a file. The commands, I'm going to teach you about some commands in the upcoming video, but let's just say the commands, your hard drives, your USBs, your personal data, I'm writing PER for short, your personal data, and every other thing that your system has to offer or your operating system has to offer is a file. It can be a .txt file, it can be a .deb file, though .deb file or dep file are for packages, but yeah, they can be a .dep file as well. They can be any other file formats that is supported by the Linux operating system. Like you won't find .exe files in Linux because .exe files are generally not supported in Linux. But you would find everything designed and designated as a file. Coming to second point, small and single purpose programs. Linux offers different tools, I'm sorry, it should be tools, not tools, that can be worked with. And what are these tools? Tools like Metasploit, it's a tool. Metasploit, then Nmap. I'm going to teach you about what are these in future. These are the tools. When you download and install Linux, these things get automatically installed. Also, there are some other tools that you can download separately, like one tool which does not work anymore, like in today's world, is OSINTgram. If you know about open source intelligence, you must have heard about OSINTgram. If you haven't, it's no issue. So Linux offers small single purpose programs. These files are not like very large in nature. They range from few KBs to few MBs. So, and they serve single purpose. Third is the ability to chain programs together to perform complex tasks. I've written kind of like linked list. Let me just clear the screen so that you can see better. Kind of like linked lists. If you are from the Windows world, you would see you have a file which is located inside a folder. Which is located inside the, say, desktop. This desktop is located under, say, the home folder or the user folder. And lastly, this entire thing is located under your operating system. So if you know linked lists, you would see, like in linked list we have data, D for short, data, and a pointer that points to the next node. Same kind of thing happens here. You have a file which has the data and a pointer. It points to the next consecutive folder. The folder contains the data and the pointer which points to the desktop. Similarly, from desktop to home directory and from home to OS. So it kind of works like a linked list. Coming to fourth point, the Linux philosophy is avoid captive user interface, UI for short. Now, although like I'm going to show you like this entire thing which I'm selecting, this entire thing, okay, it is a graphical user interface. But Linux wasn't mainly used for graphical user interface works. It mainly relies on the terminal, or which you can call shell, because terminal shell offers greater control over the operating system. Now why is that? When I'm going to teach you commands, you would see that there are some files which are kind of hidden in nature. It's just an example. Okay, there are many more examples about why you would have a greater control over the operating system through the terminal or the shell. So anyways, coming back to the topic, suppose you have a file which is hidden in nature. If you go to the graphical user interface. Now since it is hidden, you won't be able to see it. You won't be able to see it although you are logged in as a user. Like you are the sole owner of your system. You are using your system as the sole owner. Yet you won't be able to see or access the file. But if you use a shell or a terminal and with special permissions, I'm writing special SPL for short and PRM, permissions for short. So if you try to access the file in the shell with special permissions, it is highly likely that you will be able to access that file. So this is one of the examples to help you understand why the terminal or the shell offers a greater control over the operating system. Next up, the last point is config data or configuration data is stored in a .txt file or a text file. Now what does this mean? Your data, like if you have seen my Kali Linux installation video, you would have seen a portion where we have to set our username and our password. Okay. Now if you log into the system and with the right commands, you will be able to locate this username and password. Okay, they are stored somewhere in the system. Okay. And these informations like your username, your password, the name of the the host name, everything is stored in a text file. Like for example, if you try to look up the username and the password, it's generally found in /etc/password file. Okay, you would find that the username and password is stored in a .txt file. I'm going to talk about these files, about how to access them and all of that later in another video. So this was it about the Linux philosophy. Coming to the components of Linux. Linux has various components which it utilizes to run the whole operating system. The first comes the bootloader. Now what is this bootloader? Bootloader is actually a piece of code that runs the booting process to start the operating system. So let's say you have a system and you haven't installed an operating system into it. So does that mean that your system won't work? No, it does not mean like that. If you turn on your system, you would find a very minimalistic user interface, or a very minimalistic user interface in which you can only interact with your system via commands, special commands. So this minimalistic system, okay, via which you can interact with your PC or your laptop via commands, is called the bootloader. It is this piece of code that helps the operating system to boot up or to start up. When you press the power button on your PC or your laptops, it is first that this bootloader gets activated, and then in turn this bootloader starts the operating system. An example of bootloader is grub, grub. Now I will talk about it later. Okay, an important, like not important, a fun fact, I learned about this group in a very bad manner. Okay, my system got crashed and I had no control over my system except the group bootloader. So yeah, it was a horrific experience for me. Anyways, Coming back to the topic, second component of Linux is the operating system kernel. I have talked about kernel like again and again and again. Okay, it's the interface between the software and the hardware. It's the middleman through which software and hardware communicate with each other. Third component is daemons. Daemons is a new term. Now what is this daemons? When you boot up an operating system, there are many things that work in the background. There are many files that keep on running in the background as long as the system is booted up. The system is on. As long as the system is on, these files keep on running in the background. These background services are called daemons. These background services are called daemons. Now I will show you some daemons when I teach you some commands, but right now just remember it as the essential background services that are necessary for the operating system to keep running are called daemons. Next component is the operating system shell. I have talked about it earlier. It's the command line interface between the user and the operating system. Example, ZSH, bash, fish. If you have seen my first video, I have talked about different types of shells, so you would find more about that topic in that video. Next component is the graphics server. Okay, it's a graphical subsystem that allows graphical programs to run locally or remotely. Graphical programs like, let me say, like an example is this editor, this OBS editor. I am using an OBS editor. Okay, so it's a graphical application, not a terminal application or a command line application. It's a graphical application. Everything you do is in an user interface mode. So how do these like graphical programs run? It runs with the help of graphics server, where it provides a graphical subsystem, also called as the X system, which allows programs like OBS Studio to run. Next up, we have the window manager, the graphical user interface, which is this one. Like the entire screen, you can see the entire screen. Okay, the entire screen which is visible to you, it's the graphical user interface. And lastly, we have utilities, apps that perform particular functions. Now what are these apps? These apps can be anything, say Discord, say games like Minecraft, anything. Okay, these apps can be anything. So these are some examples of utilities. So this was it for today's video. I'm going to recap in a very short manner the Linux architecture. They are layered into 4 layers: the hardware, which contains RAM, CPU, hard drive, etc., the kernel, which is the interface between the software and the hardware, the shell, which is the command line interface, and the system utility, the operating system functions that are available to the user. Coming to the Linux philosophy, everything is a file. Okay, your hard drives, USB, commands, everything that you can find in the operating system is a file. Linux has small single purpose programs. Okay, they offer tools that can be worked with. They have small, like they range into from few KBs to just few MBs, and they serve a single purpose. Examples: Nmap, OSINTgram, Metasploit, settoolkit, etc. Third point, ability to chain programs together to perform complex tasks, kind of like linked lists. So I'm going to talk about it more in my file hierarchy video. Okay, but essentially every file is connected to every folder, which you can also call it as directory. and they kind of form a chain which can be also seen in linked list, where we have the data and the pointer to the next node. So the file has the data and also the pointer to the folder. That folder has a data and also the pointer to, say, the next folder, and so on. Avoid captive UI. Linux does not believe in such what would I say, a hi-fi graphical user interface. They mainly focus on the terminal and shell because it offers greater control over the operating system. The fifth is configuration data are stored in a text file. Every configuration data, your username, your password, your host name, your just your name, everything is stored in a text file. Now coming to components of Linux, we have bootloader, the piece of code that helps that runs during the booting process to start the operating system. Example is grub. We have OS kernel, again I have talked about it. We have daemons. What are daemons? The background services that keep on running until the operating system is shut down are called daemons. It can be your graphical systems, it can be other systems as well. The OS shell, I have talked about it earlier. The command line interface. The graphics server, what is this graphics server? Basically it provides a graphical subsystem, also called the X system, which allows graphical programs to run locally or remotely. Now what are these graphical programs? Like OBS Studio. Okay, it's an application to record videos and also edit them. So you can't run OBS Studio on a terminal, right? You have to have a graphical user interface. So these are the graphical programs. Now with the window manager, the graphical user interface, everything you see inside this like in the screen, the words, the letters, my mouse cursor moving here and there, the random things that I draw, everything is a graphical user interface. Lastly, utilities, apps that perform particular functions. Now what are these apps? These apps can be Discord, Facebook, Instagram, Minecraft, etc. So that was it for today's video. I hope you learned something new in today's video. If you did, make sure to like the video and also subscribe to the channel. Thank you.